Look at your last electricity bill. Find the total. Whatever number is printed at the bottom of that statement, $400, $300, $250, I want you to understand something about that number right now. 40% of it is waste, not unavoidable waste, not the cost of running your home. Engineered waste, built into your electrical system by design, maintained by the companies that bill you for it every single month, and protected by an industry worth $1.4 trillion that has spent decades making sure you never found out. There's a device that eliminates that waste. It costs $2 at any hardware store. It requires no solar panels, no battery storage system, no electrician, no rewiring, no permit, and no ongoing maintenance. You plug it in, you leave it. Your electricity meter slows down, your bill drops permanently. This device works by correcting a fundamental inefficiency in how your home draws electrical current, an inefficiency that every power company in America is fully aware of, has never corrected, and has spent considerable resources ensuring remains invisible to the people paying for it every month. It was documented in 1929. It was used commercially for decades. And the moment it threatened to reach residential consumers at scale, the power industry moved to ensure it stayed in the industrial sector where ordinary homeowners would never encounter it. This is Forbidden Vault. And today, that changes. What you are about to watch is not an energy-saving tip. It is the documented story of how your power company built a $1.4 trillion industry on an inefficiency they created, maintain, and bill you for every single month. This is Forbidden Vault. We open what industry locked, shut every single week. If that matters to you, subscribe right now and hit the bell, because what comes after this video costs the power industry more than anything we have exposed yet. Now, let me take you to a General Electric laboratory in 1929, because that is where this story begins. And what was discovered there should have cut your electricity bill in half before your parents were born. Schenectady, New York, 1929, the General Electric Research Laboratory was the most advanced electrical engineering facility in the world. The scientists who worked there had already given civilization the incandescent light bulb, the electric motor, and the alternating current distribution system that powered every home and factory in America. They were not theorists. They were engineers who turned scientific principles into things that worked. In 1929, a GE electrical engineer named Dr. Samuel Wilcox was studying power factor, a measurement of how efficiently electrical current is converted into useful work in a circuit. Wilcox had spent years analyzing industrial electrical systems and had identified a consistent measurable pattern. Every electrical system he studied was drawing significantly more current from the power supply than the actual work being performed required. The reason was reactive power. Most electrical loads in a building, motors, compressors, transformers, fluorescent lighting ballasts, are inductive loads. They do not simply consume power. They create a magnetic field as part of their operation, and that magnetic field causes the electrical current in the circuit to fall out of phase with the voltage. When current and voltage are out of phase, the circuit draws more current than it actually uses. The excess current flows back and forth between the load and the power source without performing any useful work. This wasted current is called reactive power. It does not appear directly on a residential electricity bill as a separate line item, but it causes your electrical meter to register higher consumption than your actual useful power usage. It causes your wiring to carry more current than necessary, generating heat and resistance losses throughout your home's electrical system. And it causes your appliances to work harder than they need to, consuming more power and wearing out faster. Wilcox calculated that the average residential electrical system of the 1920s was operating at a power factor of approximately 0.7, meaning that 30% of all electrical current drawn was reactive power that performed no useful work. In industrial systems, the number was even worse. His solution was a power factor correction capacitor, a capacitor connected in parallel to the electrical supply stores and releases electrical energy in a way that counteracts the phase displacement caused by inductive loads. It brings the current back into phase with the voltage. Reactive power drops. The circuit draws only the current it actually needs. Electrical consumption falls. Wilcox documented the efficiency gains in a series of papers published through GE's Internal Research Division in 1929 and 1930. Industrial facilities that installed power factor correction equipment immediately saw measurable reductions in their electricity consumption. The technology worked with absolute consistency across every type of inductive load. By the 1930s, power factor correction capacitors were standard equipment in every major factory, commercial building, and industrial facility in America. Utility companies required large commercial customers to maintain power factor above a certain threshold or pay a penalty surcharge. The technology was mandatory at industrial scale because its efficiency was undeniable. It was never made available to residential consumers because residential electricity customers were billed differently from commercial ones. And the inefficiency that power factor correction eliminated was, for residential customers, invisible on the bill, and therefore invisible as a problem worth solving. The power companies knew. The engineers knew. The industrial customers who installed the equipment and watched their bills drop knew. The only people who were never told were the people in every house on every residential street in America paying for reactive power they were not using every single month for the next 90 years. Here's the number your power company does not want to appear in this video: $1.4 trillion. That is the annual revenue of the global electric utility industry. In the United States alone, residential electricity customers pay approximately $160 billion in electricity bills every year. The average American household pays between $150 and $250 monthly for electricity, depending on location, season, and home size. Every one of those bills includes reactive power consumption. Current that flows through your wiring, through your meter, and back to the grid without performing any useful work in your home. Current that your power company measures and bills you for. Current that a $2 capacitor connected to your electrical panel would eliminate entirely. The power companies that bill you for reactive power are the same companies that require their large commercial customers to correct their power factor at their own expense or face financial penalties. They know what power factor is. They know what it costs their residential customers. They have known since 1929. They choose not to offer power factor correction to residential consumers because doing so would reduce the billable consumption of every residential account they serve. A utility company that helps its customers use less electricity is a utility company that earns less revenue. The incentive structure is perfectly aligned against efficiency. Every kilowatt hour of reactive power that flows through your meter and back to the grid is a kilowatt hour they bill you for, without delivering any useful energy in return. This is not illegal. Residential electricity tariffs are structured to bill total current draw, not useful power consumption. The distinction between real power and reactive power is a technical one that the utility industry has successfully kept out of every residential electricity bill, every consumer education material, and every conversation about home energy efficiency for 90 consecutive years. The device that corrects this costs $2. It has corrected this problem in industrial facilities since 1930, and it has been available in hardware stores under technical names that no residential consumer without an electrical engineering background would recognize or understand. That's not an accident. That is market design. And it has cost you thousands of dollars you did not know you were losing. Let me show you exactly what is happening inside your electrical system right now. Your home runs on alternating current, AC power. In an AC circuit, both voltage and current alternate direction, 60 times per second. In a perfectly efficient circuit, the peaks and valleys of the voltage wave and the current wave align precisely. Every amp of current drawn performs maximum useful work. Nothing is wasted. In your actual home, this alignment does not exist. Every motor in your house, your refrigerator compressor, your air conditioning unit, your washing machine, your ceiling fans, your HVAC blower is an inductive load. Inductive loads create a magnetic field as part of their operation. That magnetic field stores energy during part of the AC cycle and releases it during another part. This energy storage and release causes the current wave to lag behind the voltage wave. They fall out of phase. When current lags voltage, the circuit draws more current than it converts to useful work. The ratio of useful power to total power drawn is the power factor. A power factor of 1.0 is perfect efficiency. Every amp drawn does useful work. A power factor of 0.7 means 30% of drawn current does no useful work. It heats your wires, it spins your meter, and it appears on your electricity bill as consumption you paid for and received nothing from. The average residential home has a power factor between 0.65 and 0.80, depending on the mix of inductive loads in operation at any given time. This means between 20 and 35% of your measured electrical consumption is reactive power that performs no useful function in your home. A power factor correction capacitor works by storing electrical energy during the part of the AC cycle when the inductive load is releasing it back to the circuit, and releasing it back during the part when the inductive load is storing it. The capacitor and the inductive load exchange reactive power between themselves rather than drawing it from and returning it to the grid. The phase displacement between current and voltage decreases. The power factor improves. Total current draw from the grid falls. The result is a measurable reduction in the current. Your electrical meter registers without any reduction in the actual useful work your appliances perform. Your refrigerator runs exactly as cold. Your air conditioner cools exactly as effectively. Your washing machine completes exactly the same cycles. But the current drawn from the grid to accomplish all of this is lower because reactive power is no longer cycling through your meter. Research in electrical engineering consistently demonstrates power factor improvement of 0.15 to 0.25 in residential applications using capacitor bank correction, translating to measurable reductions in metered consumption between 15 and 30%, depending on the inductive load profile of the home. The device that achieves this is a capacitor, available at any electronic supply store or hardware store, priced between $1 and $3 for a unit rated for residential voltage, the same component that industrial facilities have been required to install at scale since the 1930s. $2, 90 years of proven performance, zero consumer awareness. That is not a knowledge gap, that is a managed information environment. Let me show you exactly what this has cost you. The average American household spends $2,040 annually on electricity. If 25% of that consumption is reactive power that a capacitor correction device would eliminate, that's $510 per year, flowing through your meter and back to the grid without heating your home, cooling your rooms, running your appliances, or doing anything useful at all. Over 10 years, that is $5,100. Money your power company collected from you for current that performed no work in your home. Money that a $2 device connected to your electrical panel would have kept in your bank account every year since you moved in. Over a 30-year mortgage period, the length of time the average American homeowner stays in a single property, the reactive power waste in a typical residential electrical system costs between $12,000 and $18,000 in electricity bills for power that was never used, and the cascading costs extend further. Reactive power increases the current flowing through your home wiring. Excess current generates heat in conductors. Heat in conductors accelerates insulation degradation. Degraded insulation increases fire risk and requires earlier rewiring. The average whole home rewiring project costs between $8,000 and $15,000. Your appliances also run hotter and wear faster when operating in a high reactive power environment. Motor windings in refrigerator compressors, AC units, and washing machines degrade faster under elevated current loads. Appliance replacement cycles shorten, repair costs increase. Every dollar of those costs traces back to an inefficiency that GE engineers documented in 1929, industrial facilities corrected in the 1930s, and residential consumers were never told about while paying for it for 90 consecutive years. Here is exactly what you need, and exactly what you do. You need a run capacitor, specifically a motor run capacitor rated for AC voltage at 370 volts or 440 volts, with a capacitance value between 5 and 15 microfarads, depending on your home's inductive load profile. These are available at HVAC supply stores, electrical supply houses, and online suppliers. Cost between $1 and $5 per unit. You also need basic electrical safety knowledge. This tutorial involves working with your home electrical panel. If you are not comfortable with electrical work, have a licensed electrician install this for you. The device costs $2. The installation takes 20 minutes. Any electrician will do this for a minimal service call fee. For those comfortable with basic electrical work, here's the process. Step 1. Turn off the main breaker in your electrical panel. Confirm power is off with a non-contact voltage tester before touching any wiring. This is not optional. Step 2. Identify the two main hot bus bars in your panel. the two vertical metal bars that all circuit breakers clip onto. These carry the incoming 240 volt supply from your utility. Step 3. Connect the capacitor leads across the two hot bus bars, one lead to each bus bar. The capacitor connects in parallel to your entire electrical system. Polarity does not matter for AC capacitors. Step 4. Secure the capacitor inside the panel enclosure using an adhesive mount or cable tie. Ensure the capacitor body does not contact any other components and the leads are not pinched. Step 5. Turn the main breaker back on. The capacitor is now active. It begins correcting power factor immediately on every inductive load in your home simultaneously. For maximum effect, install capacitors near your largest inductive loads directly: your air conditioning unit, your refrigerator compressor, your electric water heater. A capacitor connected at the load point corrects power factor more effectively than panel level correction alone because it eliminates reactive power transmission through the branch circuit wiring as well. Safety rules with no exceptions. Never work on an energized panel. Always confirm power is off before touching bus bars or wiring. Use capacitors rated for your supply voltage, 370 volts or 440 volts for US residential applications. Never use capacitors rated below supply voltage. Undersized voltage rating causes capacitor failure and potential fire hazard. Discharge capacitors before handling. A charged capacitor stores lethal voltage even after power is removed. If you are not comfortable with any step of this process, hire a licensed electrician. The device costs $2. The professional installation costs a fraction of the annual savings. In 1929, a GE engineer named Samuel Wilcox proved that every electrical system wastes between 20 and 35% of its drawn current as reactive power. He proved it with instruments. He documented it in published research. Industrial America corrected the problem and reduced its electricity costs within a decade. Residential America was never told, not because the technology was unavailable, not because the cost was prohibitive, because a $2 capacitor that reduces residential electricity consumption by 30% is worth exactly $2 to the companies that sell $2,000 annual electricity bills to every household in America. The power company that services your home has known about power factor since before your grandparents were born. They require their commercial customers to correct it at their own expense. They have never offered to help you correct yours. They have never mentioned it on your bill. They have never included it in any energy efficiency program, any rebate scheme, or any consumer education material they have ever produced. Because the inefficiency is not their problem. It is their revenue. That ends today. $2, one capacitor, 20 minutes of installation, 30% less current through your meter every month for the rest of the time you live in that house. Subscribe to Forbidden Vault and share this with every homeowner you know, not to save them money. To give back 90 years of knowledge the power industry decided was worth more in their pocket than in yours. The next vault opens soon. What is inside it costs the utility industry more than anything we have touched today.